from NOAA-NESDIS. The title of today's talk is Late Season Atlantic Extratropical Cyclone. Our facilitator today is Emma Trask from the GEO program, who was a LaPenta Scholar intern from last summer. A few reminders before we get started. The session is being recorded. See the pinned message in the chat for the Privacy Act information. We will be doing question and answer after the presentation, so if you have any questions, post those questions in the chat. If you're interested in presenting in the future, fill out the form in the chat. We're always looking for future presenters. If you have any feedback, do see the chat for a feedback form. If you'd like training assistance in the future, please contact Ross Van Til. And thank you to ACLO, the GEO and LEO programs for their support. So introducing today's speaker, Chris Smith graduated from the University of Maryland with a master's degree in Atmospheric and Oceanic Science. Chris's first role was a contractor with the NESDIS Systems Architecture and Engineering branch to maintain and update NOAA's user observational requirements that inform the organization's observing system architecture. In October of 2023, Chris joined the Cooperative Institute for Satellite Earth Systems Studies, or CISESS, as the GOES-R Satellite Liaison for the Weather Service, Weather and Ocean Prediction Centers, helping to make satellite imagery and products available to forecasters while also delivering feedback to the product developers to maximize product capability. So now I'll hand it over to our presenter, Chris, to begin today's Satellite Book Club session.
Sorry, Chris, can you speak again? Sorry about that.
Yeah, no, you're good. I'm here now, so thank you. All right, next slide, please. Thanks for the introduction, Dan. So today I will be discussing a late season extratropical cyclone monitored by the Ocean Prediction Center and the GOES-R Satellite Liaison for the Ocean Prediction Center and the Weather Prediction Center, working out of CISESS, or the Cooperative Institute for Satellite Earth System Studies. So today I'll be giving an overview of this system, and it'll just be a good reminder of the toolkit we have at OPC, especially in terms of satellite before our busy season starts up in the fall. Next slide, please. So I just wanted to show hurricane force averages by month. The storm I'm actually talking about today reached storm force, but in terms of general activity, it does follow this pattern. So from 2005 to 2022, you can see similar trends in the amount of hurricane force lows per month, definitely starting to ramp up as we enter the fall, peaking in the winter, and really quieting down over the summer. And you can see for the number of hurricane force lows on this 17-year average, we have about 45 wind events per month in the Atlantic. So when you think about how many named hurricanes there are by the Hurricane Center, we have about 45 of those events with hurricane force winds per season in the Atlantic. Next slide, please. So the system we're looking at is a storm force in late April. So when the weather's really quieting down in the North Atlantic, our 96-hour surface forecast chart, that's the one that goes the furthest out for 4 days. You can see we're looking in the Northwest Atlantic for developing storms, 45-knot winds there, and this is 4 days in advance. Next slide, please. If you can play that video, you'll see the GOES East Air Mass RGB 24-hour loop from 6 UTC on the 20th to the 21st. And what we're looking at here is a cold front moving off the East Coast, and then you see the low pressure getting really enveloped in this dark orange or red color, indicating a tropospheric fold upstream, some high stratospheric potential vorticity air, and that really fueled the system to strengthen as it moved into the Northwest Atlantic. By the end of the animation, you can see some really well-defined frontal features, a cold front, warm front, and a strong inclusion as the system really reached its first mature phase there. Next slide, please. All right. So this was the 24-hour pressure change. So as the system was just moving off the east coast there of New England and southeastern Canada, you can see it was developing gale. So in the next 24 hours is expected to have at least gale force winds with a minimum pressure around 998 millibars. Next, please. And then 24 hours later, strengthened pretty fast to a 982 millibar storm force low just as it entered the Western Atlantic there. You also notice on the surface chart, those blue dots are actually where the ice edge is provided by the US NIC, National Ice Center, which is part of the Ocean Prediction Center. So if temperatures were cold enough, you would also see something called a freezing spray label, which is really hazardous to mariners since it can accrete on ships and weigh them down. But here we just have a storm force low as it's entering the North Atlantic. So at 10 UTC that day, we did actually get a SAR pass just south of Newfoundland. So this was on the southern quadrant of the storm after it passed through this area. So behind the cold front, we can see some 45 knot winds there. So just below storm force, but some strong gales. And SAR winds are really nice because they provide very high resolution, around 500 meters compared to scatterometers, which is around 12.5 kilometers. So you can see some neat features in the SAR winds, some gradients there like in the middle of the image and some lighter winds on the top right. A lot of detail that we're hoping to explore this winter and see some structures in extratropical cyclones that we haven't seen before. Next slide, please. The Polar Planner is a tool I keep promoting. Thanks to Tower S for our forecasters to use. We do have surface analyses, for example, in the Atlantic at 12Z that gets sent out a couple hours later. And a lot of our forecasters always want to know if a scatterometer pass will be available to help inform their map. So here I have, for example, in the Western Atlantic, this is just from yesterday, we have a METOP B pass around 1345 UTC. If you go to the next slide. We have OSCAT around 16 UTC. So for every day in the Atlantic, they are spaced about 2 to 3 hours behind around that time. And this just allows our forecasters to know if they should wait on a pass or not. With the latencies, the passes come into AWIPS around the same time every day. But this is a really great tool if you're wondering when the next pass will be for ocean surface winds or wave heights and things like that. Next slide, please. So this is a METOP C pass. This is from 2 passes from 12 to about 1430 UTC. Our forecasters like to overlay multiple ASCAT passes at a time so you can see the whole wind field of a system. So for example, you can see ahead of the cold front to the right where you have southerly winds, you have northwest winds behind the cold front. And at this point, the system had dropped just below storm force again, so it was a strong gale. And ASCAT was noting some 40 knot winds in the southern quadrant. And we saw those in the SAR winds as well. Next slide, please. And then again, about 2 hours later, OSCAT came in. We can already see the system is starting to change structure a little bit. We have those really strong winds in the southern quadrant, but also an area of gale force definitely showing up in the northern and northwestern quadrants there. For OSCAT, it's important to sample, especially if you see some Arrhenius high wind values because it is a KU band scatterometer. It's more sensitive to rain attenuation, but sometimes it can also detect higher wind speeds than ASCAT in some rain-free conditions. So for this one here, I did sample and there was a rain rate that was showing. So some of these higher wind barbs in the northern quadrant could be questionable. Next slide, please. And I always like to underlay imagery behind just to confirm what I'm seeing with that rain rate flag. If it's in an area of more intense convection, we can see in the geocolor imagery here, we do have some thick cloud cover behind where there's a couple 50 knot wind barbs. So this is a gale force low at the time, but those would have indicated a storm force. We decided to just go with the larger background consensus of the winds here because those were likely contaminated by rain with the imagery and rain sampling flag confirming that. Next slide, please. We also, around the same time as OSCAT, we do have microwave wind speeds in AWIPS as well. So this is from AMSTER 2. They really give a nice wide swath like OSCAT. No wind direction from these microwave-derived wind speeds, but you can see it did confirm those strengthening winds in the northern quadrant that we saw in OSCAP a couple hours later after the ASCAP passes. So this was a nice validation of what we saw in OSCAP provided by the microwave winds there. Next slide, please. And then wave height observations, obviously really these winds drive massive waves in the North Atlantic. We have Sentinel 3B pass right around those times of those ASCAP passes, and we can see wave heights there up to 22 feet. So definitely would be hazardous for a mariner, and a lot of passes you can see behind. So we have about 6 altimeters in AWIPS altogether. So some good coverage of wave heights with those point set measurements. Next slide, please. So our 72-hour forecast for that time period verified quite well. You can see 45-knot winds, which we did see pretty much in the SAR wind pass, and wave heights up to 6 meters. So our wind wave forecasts that go out to 96 hours are in meters there. 6-meter waves are around 20 feet. So what the altimeter showed is that this verified pretty well, which was a good forecast at OPC. Next slide, please. Something else we're looking at is the sea spray RGB. I briefly mentioned that freezing spray is a really large hazard for mariners at sea. And while this wasn't a freezing spray scenario, this was a good case to capture some of the applications of that RGB there. So it's a very subtle signal, a lot of sun glint in this animation. So we have a lot of red in the background. But if you look at that milky gray color, which leads into some cloud streaks on the southwest side, that is actually sea spray. This is the GOES sea spray RGB for about 2 hours there in the afternoon of April 21st. And when systems are around storm force or greater, we usually can see sea spray in satellite imagery. So we did indicate that there. Next slide, please. And we can look when the VIIRS pass comes over Bill line, and as the stars also developed the sea spray RGB for JPSS satellites. And we see that same signal, a very subtle milky gray color leading to cloud streaks in the same direction. That usually is a good indicator of sea spray there. Next slide. So this is the next day as the system's pushing east, and we usually do see systems get some terrain enhancement here from the tip jet south of Greenland. So you can see OSCAT the next day, again, had winds in excess of 50 knots. But this time when you're sampling with the rain rate, there is no rain present. So this actually is indicating pretty valid storm force winds here. And you can see a large area of that well removed to the north of the actual cyclone here. And you can see the OSCAT provides a very large swath, so you can see much of the wind field of the storm system at the same time. Next slide, please. So this is a heat map just showing hurricane force low climatology for April in the Atlantic based on that same 17-year average I presented earlier. And while this was a storm force low, the general areas of activity are the same. And you can see where that system tracked from the Northwest Atlantic, south of Greenland. And that terrain enhancement there on southeast of Greenland is a favored area for really hazardous weather, even into April in the Atlantic. Next slide. So our surface analysis at that time did show storm force winds. You can see they were well north of where the actual low pressure was, with a minimum pressure of 981 millibars. Storm force winds there, and you can see, again, if temperatures were cold enough, we might have had a label for freezing spray. The ice edge is all around Greenland at this time. Next slide. So this is heading into the next day. We can look at marine traffic from marinetraffic.com and just verify some vessel avoidance. So you can see that track from Newfoundland up toward Northern Europe. There's really not a lot of ships there, especially as you get closer to Greenland, which is a good sign because we did have storm force winds at that time. Next slide. And our surface analysis the next day showed that the system really was maturing. You can see a strong inclusion at that point, 2 cold fronts, a 987 millibar low. So weakening some, but you still see those storm force winds backed up against southern and eastern Greenland there. So now looking forward to this winter, some tools that we're hoping to leverage. I showed those SAR winds at the beginning because we did actually experiment with SAR task ordering last winter. We're hoping to leverage that this winter. So you can actually go to the Sentinel site and see acquisitions that are planned for the next couple weeks ahead. And there'll be KML files that you can load into Google Earth and see the type of polarizations there and where the tracks will be. So if on our OPC charts, we have 3 or 4 days notice of a hurricane force low and where it may be, we can actually reach out to Chris Jackson's team, who presented here a couple months ago on SAR winds, and get an acquisition there and look at that actual SAR wind footprint. So we're hoping to leverage that this winter and see some neat structures and powerful extratropical cyclones. We're also hoping to leverage Gremlin this winter in experimental capacity. So we do, in those weather grids there off the East Coast, have text for showers and thunderstorms. Obviously, we've never had radar out there before, but having this simulation of radar reflectivities from Gremlin could provide some value to verify our forecasts or update them. That's actually Hurricane Erin from yesterday. You can almost see that eye-like feature just south of our grid there in the bottom right. So that's something we're hoping to use this winter. SAR winds, I've talked about them a lot, how we're hoping to task order them. Obviously, if we're task ordering them, we want to see them in AWIPS and not just online. So we are working with Tower S to get those into our system. I stole this from one of their guides for the latest RPM for the WFOs, but you can see the SAR winds there for some Great Lakes and coastal WFOs, and just the high resolution there compared to the scatterometers that we currently have in AWIPS. Next slide, please. And we actually don't have a great sea surface temperature data set in AWIPS at the Ocean Prediction Center. We're working with OSPO and NASA Sport to look at some sea surface temperature products that we can get into AWIPS. So NASA Sport has provided us with configurations to view this 7-day composite sea surface temperature and sea surface temperature anomaly product. Really important, since storms usually ride along those gradients like the Gulf Stream in the Western Atlantic or Horatio Current in the Western Pacific. And with those anomalies, you can really get some higher wind speeds and see where the storm tracks will be and verify models farther in advance. We're also looking to get Meteosat 3rd generation into AWIPS. Still, I know Taras is working on that for us. We do forecast all the way out toward Europe. So having that 1 kilometer IR imagery, for example, from Meteosat 3rd generation will be a great asset. And WSFM, the follow-on to DMSP, getting some microwave imagery so we can evaluate the structure of extratropical cyclones is something else we're looking forward to this winter. Next slide, please. And since we are having some impacts from Erin today in our basin, I did want to include that so you can see, even though Hurricane Erin is the National Hurricane Center's forecast responsibility, we do have to include that in our grids and labels at the Ocean Prediction Center and coordinate with the Hurricane Center. So this was a 48-hour forecast from yesterday, so about 24 hours from now. You can see the hurricane out there in the Western Atlantic, which had some pretty big impacts, which I'll show you on the next slide. This is from the NDFD. You can see the significant wave height shown about 40 minutes from now, what you'll be expecting along the mid-Atlantic coast. So wave heights up to 16 feet near the Outer Banks, or 14 off Delmarva, 13 up to New Jersey. And you can see in the core near Erin and to the east, we're getting to the higher end of the color bar there of significant wave heights up to 50 feet. And those are the highest 1/3 average of all wave heights. So we could see some wave heights, much higher than that, up to 70 feet or so there in the Western Atlantic. So definitely a big situation that we've been monitoring and coordinating on this week. Next slide, please. So in conclusion, a late season strong extratropical cyclone affected the northwestern Atlantic with storm force winds, and we were able to leverage some new tools to see things like sea spray and verify marine vessel avoidance. And tools like OSCAT last winter really helped fill the gap in scatterometers for our forecasters at the Ocean Prediction Center. And we're looking forward to use new tools coming up this winter as our busy season really starts in the fall, including SAR wind task ordering and getting SAR winds into AWIP's new sea surface temperature data sets and more like Meteosat 3rd generation. Next slide, please. And if you have any questions, you can email me at my NOAA.gov email or my UMD email with CISESS, and happy to answer any questions now as well. Thank you.
Thanks, Chris, for your presentation today. So before we turn to audience questions, here are a couple friendly reminders. Next slide, please. So to view the facilitator and presenter during this Q&A session, please change your layout from tiled to hide tiles without video. Next slide, please. And then in 1 week, so next Thursday, Sam Stangster, Senior Meteorologist at Delta Airlines, will present on the satellite applications in Delta meteorology. Next slide, please. And then if you have any questions about the Satellite Book Club or satellite products, feel free to contact Sheila Kupai from the Tower S team. Next slide, please. And then now let's get into the audience questions. So if you have a question for Chris, feel free to type it in the chat. Chris, what feedback have you received regarding the OSCAT 3 scatterometer in AWIPS?
Yeah, so definitely our forecasters are noticing if there's an outage. It is not, operational yet. So our forecasters are loving that it's filling a gap in the scatterometers. When ASCAT passes, it's another 12 hours before you get a scatterometer pass in the Western Atlantic. So that's been a big asset there. And like I said, it does have a shorter wavelength. So while it can struggle with rain contamination and rain-free scenarios, it can actually be more sensitive to the ocean surface there and get some higher wind speeds, which we've seen as well. So definitely a big plus for our forecasters at OPC.
And we do have a question in the chat, and that is, what would you say is the Ocean Prediction Center's biggest challenge?
Yeah, it's just sitting with forecasters. I know I get a lot of questions about fog forecasting and verifying that, which we do at the Ocean Prediction Center. And then I would just say, the rate of deepening in some of these extratropical cyclones can be pretty extraordinary in the winter. So just keeping up with that in real time, if models are underdoing that, I would say is a big challenge as well.
I have another question, Chris, and I thought it would be easier just to ask verbally.
Okay.
So yesterday at the CIRO weather briefing, we were looking at Hurricane Erin, which you showed an example of there earlier with Gremlin, I think, and showed that its forecast wave heights as it moves out over the Atlantic, not necessarily along the coast, but along, relatively close to the center of the low during extratropical transition. And that reminded me of the movie in the early 90s, The Perfect Storm, which is, of course, based on a real event where some fishing boats out of Massachusetts, struggled mightily with massive waves associated with a transitioning storm. My question is, do you know how, like, the forecast from OPC or if OPC is involved at all in the communication with people like the fishing industry or the shipping industry who may be affected by these extratropical lows?
Yeah, so I don't know if someone at OPC is online, but I know they do, the nav text, and they have these products that get sent directly to ships as well. Also doing just IDSS activities, key messages, for example, to the U.S. Coast Guard. So for an event like this, that's really impactful. And we can, again, see like on marinetraffic.com where the vessels are located, and we've seen a lot of avoidance verifying for this system, which had a lot of publicity. So myriad of things, but there may be more details from someone from OPC online.
And then we have a couple more questions in the chat. So Jack Dostalik asked, do you interact directly with shipping companies? If so, what does that look like?
Yeah, I would say it was the same to Dan's question. I know sending our products out, I don't know about direct shipping companies or routing or anything like that. We don't do any routing, but we do try to interact with them. We have Mariner workshops every year where we invite people from the private sector to learn more about our products and hear about some of their challenges. And again, just making sure vessels are being avoided. We also do spot forecasts if vessels are in any type of distress. We usually provide forecasts on that with coordination from the Aviation Weather Center if they're in distress and need a rescue or something like that.
And then John Forsyth also said, great talk, Chris. You mentioned WSF M1. It has polarimetric channels to receive sea surface wind vector. Any updates on OPC getting that data?
Yes, I know that we put it on our priority list to receive that. And my understanding is that the imagery channels and RGBs will be coming first, which will be very soon. We're actually trying to get that into our system in the next week or so, at least in our test system. And then the derived products to follow, which should be similar to Answer 2, for example, with those microwave winds that I showed. So hopeful that we are going to receive that.
And then not a question, but more of a comment. Cameron Anderson said, Chris has provided invaluable expertise in assisting our forecasters at OPC regarding all things satellite and remote sensing capability socialization.
Thanks, Cameron. We appreciate it.
Any other questions in the chat for Chris?
While we wait for someone to post, I'm going to use this opportunity to ask Emma, if that's okay. How was your La Pinta intern experience from last summer?
It was fantastic. I don't think I would have enjoyed doing anything else as much as I enjoyed getting to be on the Tower S team and getting to learn all about, what happens within NOAA. I feel like those 10 weeks that I spent in Silver Spring were some of the most invaluable, I think, weeks of my career so far.
That's awesome. And yeah, I was corrected in the chat. This summer, not last summer. I get mixed up on the year. Well, that's really great to hear. I'm glad. I really like that program, and getting that sort of feedback is good to pass along to potential future folks who might want to apply for it. So thank you for that. So glad you hear that you had a good experience.
Yes, thank you. I see no new questions in the chat, but Chris, I was going to ask you, does the OPC provide any IDSS for impactful systems such as Aaron?
Yeah, so for example, for this one with the U.S. Coast Guard, we've been sending out key messages multiple times a day, and we'll talk about the wave heights and wind speeds as well. So we're coordinating, across the government and publicizing on social media and things like that. We've stepped up the communication just because this is such an impactful event, especially with the wave heights. And we'll see an extratropical transition in the next 48 hours as well. So that'll become solely OPC's responsibility.
And we have another one in the chat. So this one is from Michael Jamilkowski. I'm sorry if I mispronounce your last name at all. And he asked, do you provide open ocean thunderstorm monitoring and forecasting products to ocean traffic using GOES, ABI, and GLM data?
Yeah, so right now where I showed those forecast grids on that Gremlin slide, we're actually moving those grids to full basin, I think, over the next year or two, really making a big effort for that now. So we'll be forecasting at least text for showers and thunderstorms across the whole Atlantic. That'll be a big change for us. We're only doing that over those Western regional grids right now. So I only see the need for GLM increasing to verify thunderstorms and things like that in the next year or two.
Thanks, Chris. So if there are no further questions, I will hand it back over to Dan to wrap up this week's Satellite Book Club.
We had a very late question come in right when you said that. So maybe we can let Chris answer that about the MEDUP SG.
Yeah, and I think that's the one with the microwave sounder, if I'm not mistaken. I think there will be interest in that. I know the next one to launch is the one with the scatterometer and the ASCAP follow-on, which is going to be absolutely critical for OPC. So probably both, but definitely the scatterometer launch.
All right. Thanks so much, Chris, for a really excellent presentation. And thank you, Emma, for doing a great job with the Q&A there at the end. And again, thanks everybody for coming to the Satellite Book Club. As a quick reminder, next week's session is by Sam Sangster from Delta Airlines, titled Satellite Applications in Delta Meteorology. Talk to you guys next time.